Okay, so in this video, let's understand how to handle categorical features. So usually, in the real world, in your data sets, you won't just have real values. You'll have values that are categorical in nature as well. Let's say I have a data set where I have the weight of a person as one feature, then I have the hair color as another feature, and then I have, let's say, eye color, right? And my regressor, the one that I have to predict, is, let's say, its height. Okay, so this is my regressor. Height is the y variable, and my goal is to find a function f of x such that I get the best value for y. So your weight is, I'll just take an example data point over here. Let's say your weight of a person is 120 kgs. The hair color of a person is, let's say, black, and the eye color is blue, right? So, look, generally, when you build a model, your models can't understand English like we do. They only understand numbers. And so we've understood how to deal with, English or words like this in natural language processing. If you haven't seen that playlist, you can just watch it. I have that playlist as well. But, but look, if you have something like the hair color, and one way to convert this is to give it an order. Suppose all the possible values of my hair color in this data set are, let's say, black, white, yellow, red, and pink. Okay, these are all the possible values of my hair color in the data set. So what I can do is I can give it some number. I can give black as 1, white as 2, yellow as 3, red as 4, and pink as 5. So, if you give it a number like this, you're converting into a numerical value which the model can understand. But if you look carefully, there's a problem with this. So when you give black a number 1 and a white number 2, you're sort of giving it an inherent order, because numbers 1, 2, 3, 4, 5 come one after the other. You're sort of giving it an inherent order, okay? You're giving the values an order, which is incorrect. It's not right. Because what does it mean that black is greater than white or white is greater than black? It doesn't make any sense, right? These values where you give it in, where they sort of come in an order, they're called ordinal. Okay? So it's not right to give ordinal values to your categorical variables. Instead, we go with something called the one-hot encoding. Okay, this is what is the right thing to do, and this is also very widely used in the industry. So what one hot encoding does is that instead of giving it an order like this, black is 1, white is 2, yellow 3, red 4, pink 5, what I do is I create a vector with 5 variables, black, white, yellow, red, and pink. And whatever is the value of the hair color for that particular data point, I just make that, let's say that xn over here was black. So I'll make black as 1 and I'll make the rest of them as 0. Okay, this is what you call one hot encoding. Another data point can possibly have a value, can possibly have the hair color as yellow. So I'll give that as 1 and I'll give the rest as 0. This is what you call one hot encoding, and this is the right way to go about it because you don't want to give an artificial order to your categorical variables. And if you give it a value like 1, 2, 3, 4, 5, this is what you are doing. This is essentially what you're doing. You're giving it an artificial order. So this is one hot encoding. Now look, with one hot encoding, there's another problem. The thing is, if you have a feature like, let's say, country, and there are over 200 countries, right, in the world. So, if you have something like country, you'll have a vector with 200 features. You'll have one country, two country, all the way to this 200th country, right? And for every data point, the person will belong to only one country. So in a case like this, you can have a very sparse matrix. right, for your features. Because most of your values here are zero. There'll be one value that's one, and everything else is zero. So this gives rise to a sparse matrix. And sparse matrices are not very good for models because they just make computation very heavy, and they also take a lot of space. And yeah, the model training time increases a lot if you have sparse vectors or sparse matrices. So what you do here is there's something there's a technique to convert a sparse matrix to a dense matrix. What you can do is you can use something like PCA to reduce the dimensionality of this matrix from 200 to maybe 4 or 5, and you can use that matrix as a matrix in your model. So these are some of the techniques where you can deal with sparse matrices that are formed due to one hot encoding. Another thing you can do is that, if it's problem specific, another hack to deal with sparse matrices is that, you take, so let's go over here. Over here, I have the weight of every person and the height over here, right? So if I have another feature like country, what I can do is that I can replace the particular country, the value, let's say for xn, my country is China, right? So what I can do is I can replace China with the mean value of all the heights of the people. So instead of in the country column, instead of writing China, I'll just take the mean value of all the heights of the people. Maybe it's like 154 centimeters, and I'll put it there. So this is one hack to deal with large matrices that are, very sparse in nature. Now, another thing you can do is that instead of taking the average height of all the people in that country and replacing the country with that average height, what you can do is you can maybe, these are all hacks, all right? There's no right or wrong way to go about this. These are all hacks. Another way to go about this is maybe you can take the distance of the country from the equator. Okay, maybe that has something to do with height. Maybe the higher up you move from the equator, the maybe people tend to get a little taller. So that is another thing you can do. You can take the distance of the country from the equator, and you can replace that value of country with the distance from the equator. Now these are all hacks. There's no right or wrong way to go about this. In reality, you would want to check all the features and see what performs best for your model. But if you know that there's some correlation with the height of people and the distance of the country from that equator, you can replace the distance of the country. You can replace the country with the distance from the equator. So these are all hacks, all right?